Okay, last set of notes for this unit is actually a review from the last unit that we did, which was on graphing quadratics. So we're going to look at example number 1 that is written in standard form. And we're going to look at the graph that's given, and we're going to answer each of the questions that are listed here. So we're going to start with the vertex, which we can see here on the graph. And the coordinates of that point are 4, -1. So that's 4, -1. Axis of symmetry is that vertical line that goes through your vertex, cutting your parabola in half. So it's a vertical line, so it's x equals. And then it's going through that x coordinate of 4. Okay, our domain for any parabola, any quadratic, is always going to be all real numbers. So we're going to write that as x such that x is an element of all real numbers. The range, because this quadratic or this parabola opens up, this is our lowest point. Okay, so that is a minimum value. And the lowest value here is the y coordinate of the vertex. So I'm actually going to label this here so I can point to them. So that lowest value that we get is a -1. All of our values are greater than that, and that ties into our range. So our range is y such that y is greater than or equal to that -1. So if our leading coefficient is positive, it means that our parabola is going to open up. And then the vertex is our lowest point, and our range will be all values that are greater than or equal to that lowest point. Okay, another thing that we can do pretty easily is to find the y-intercept. So the y-intercept is when you're substituting in a 0 for x. Sometimes you can see where it crosses on the y-axis. In this case, you can't. So what we're going to do is we're going to substitute in a 0 for x in both spots. And what would happen then is this would become a 0, and this would become a 0, leaving us with x is 31. So when we had an equation in standard form, that value of c actually is our y-intercept. Okay, another quick thing we can do for substituting in is this f of 2. F of 2 means that we're substituting in a 2. So 2 times 2 squared minus 16 times 2 plus 31. And you can actually enter that whole thing into your calculator at one time, as long as you're including the parentheses where they need to be, and you will get an answer of 7. And then we can go to our graph and we can see if that would make sense. So if x was 2, y would be somewhere up here, which is 7. So that seems like it's a reasonable answer. X-intercepts. X-intercepts are where we are crossing the x-axis. So if we look on our graph, we can see that they're not perfect answers. But we need to put in 0 for y. And then we've got this 2x squared minus 16x plus 31. So what we're going to do here is we're going to go for the quadratic formula in order to find out that value of x. So we're going to do the opposite of -16 is 16 plus or minus the square root of -16 squared minus 4 times 2 times 31 all over 2 times 2. What we get then is x equals 16 plus or minus, and if we substitute all of this for the x, the calculator under the square root, we end up with a b. And then we can reduce that even more, because there's a perfect square factor in 8 of 4. And so it's the square root of 4 square root of 2, which is going to make us root 2. And then, of course, we can reduce each of these terms by 2. So if we do that, we're going to have 8 plus or minus the square root of 2 all over 2. So our x-intercepts are 8 plus or minus the square root of 2 all over 2. And then we substitute it in a y in order to get that. What we can do, also, we could in our calculator or through Desmos, you could type this in and you could find out what these decimal approximations were right here. And then you could double check that with the decimal approximations here. So if you do that and you do in Desmos calculator, and you type this in, you can hover on that x-intercept and you'll see that this one is 3.290. And then this one is 4.710. And if you would take each of your x-intercepts in your calculator, these exact answers that we find, these are the decimal approximations for them. With the zeros, that's just taking the answers that you got for your x-intercept, and then you're writing it as a solution. So you can leave it like that. Okay, so if it's an x-intercept, you write it as a point. If it's a 0 or a root, you can just write it as x equals. All right, and then the last part of this example is you're going to take this value of 5, place f at 5. So this is 5 equals 2x squared minus 16x plus 31. So in order to use the quadratic formula, I need to have this equal to 0. So what we can do is subtract 5 from both sides, and we're going to have 2x squared minus 16x, and then this will be plus 26. Now you can go ahead and go right to the quadratic formula. I noticed that they're all even, so I'm going to factor out a 2 first to make the numbers that I'm using in the quadratic formula a little bit small. Okay, so I'm going to do the quad formula for what's left inside the parentheses. So my b is negative 8, so the opposite of that is 8, plus or minus a negative 8 squared minus 4 times 1 times 13 all over 2 times, remember that b value is a 1. So what I get here is 8 plus or minus, and then if you put this into your calculator all at one time, in the right spot, you're going to get a 12 here all over a 2. And then we can simplify this radical. Square root of 4 square root of 3 is going to give us 8 plus or minus 2 square root of 3 all over 2. And now we can reduce the 8, the 2, and the 2. They're all even, so we can reduce those to get 8 plus or minus the square root of 3 all over. Oops, hold on, sorry. I need to reduce all of them by 2. So sorry, divide by 2, you get 4 plus or minus, and then those 2's cancel, and that's a square root. Sorry about that. So the answer is x would be 4 plus or minus square root of 3. Okay, so that's all of those questions being answered about this graph and the function that's given there as f of x. So if we scoot down to example number 2, it's very similar. You have a new function. Difference here I see is that your leading coefficient is negative, and that's why your quadratic is opening down. So that's going to affect this min-max in this range. So let's look at your vertex, which is going to be negative 1, 1. And then the axis of symmetries, that vertical line that cuts your parabola in half, that's x equals negative 1. Domain for quadratics will always be all real numbers. And then our range is a little different. So because your parabola is reflected or has this negative, it's opening down, it means that our vertex is a max value. And that maximum value that we have is a 1. What that means for your range is that that max value is where your range ends. Everything else is less than. So here in example 2, we have a parabola or a quadratic that opens down. So all of our y values are less than 1. And in example number 1, we had a quadratic that opened up. So all of our y values were greater than that y coordinate of the vertex. All right, so example number 2. Your y-intercept, number 2, or x. So if you put in a 0 for x in the standard form of this function, this -3 times 0 would be 0. -6 times 0 is 0. -2 would be -2. You also could have seen that right here on the graph. Okay, we're going to substitute in -3 here, f of -3. We're going to have -3 times -3 squared. Make sure you're putting that in parentheses. And then -6 times -3. Again, make sure you're putting that in parentheses. And what you should be getting if you do this correctly is a -11. All right, we'll go back up to the x-intercept. So the x-intercept means that you are setting your function equal to 0. And then what you're going to do is do the quadratic formula on this. So for the x-intercept, you're going to write your answers as a point. And then you're going to use that same answer and write x equals 4 0. Okay, so pause the video right now and do not come back here until you've found the x-intercepts with the quad formula. Okay, so I have all the work here for finding the x-intercept. Once you substitute everything into the quadratic formula, what you will get underneath the square root is a 12. Square root of 12 will be square root of 4 times square root of 3. So that's where this 2 square root of 3 comes from. And then you can take your 6, your 2, and your -6, and you can reduce those each by 2 because they're all even. And what we get then is 3 plus or minus the square root of 3 over -3. I'm okay if you're taking this -3 and you're putting it up here instead. It is the same answer. Both of them are correct. All right, so for the x-intercept, we write it as a point. For the 0 or the root, we write it as x equals. All right, example number 2, last part, f of x equals -5. That means your entire function is equal to -5. So -3x squared minus 6x minus 2. You're going to add 5. So -3x squared minus 6x plus 3. So once again, just like we did for the x-intercept, we're going to need to use the quadratic formula here. So I'm going to pause the video. I'm going to have you do the quad formula on that, and then come back and check your answer. Okay, so here's my answer. I want to explain to you what I did in case you did something that was different, but we still should get the same answer. So what I did in underneath the red is I noticed that each of these was divisible by 3. So I actually took a -3 out. So I used CF of -3 out of each one of these to make the numbers I was putting into the quadratic formula smaller. So my A is 1, my B is 2, and my C was -1. So I substituted those into the quadratic formula. I ended up with an 8 underneath the radical. So root 4 times root 2 would be 2 root 2. And then I have a 2 in each one of these. So if I divide each of these by 2, here's how I ended up with -1 plus minus the square root. If you had used the -3 as your A, the -6 as your B, and the 3 as your C, you would have just had something that you would have had to reduce more. Still should have come out with the right answer, the same answer, I should say. All right, let's go to the back. And we're going to take a look at trying to analyze some of these important pieces of a function's graph without actually having the graph to look at. So what I see when I'm given, so this is vertex form. So I know that my vertex is 1, negative 3. That number in front is positive. That tells me that my quadratic is spinning up. And what I also know then about that is that the vertex contains the minimum point of the graph. So this is the lowest that my y values can get. So everything else will be greater than. Okay, so greater than what? Greater than the y coordinate of the vertex, negative 3. Okay, and then for the y-intercept, just like we did on the foot, we're going to substitute in 0 for x. Only we actually have to substitute it into vertex form. We can't look at it to see what the y-intercept would be. So we're going to equals 4 times 0 minus 1 squared minus 3. So 4 equal, or y equals 4 times negative 1 squared minus 3. You can type that all into your calculator at one time. What you should end up with is a 1. So my y-intercept there is 0, 1. For my zeros, that just means I'm going to look for the x-intercepts and I'm going to write them as solutions. So I'm setting this equal to 0. So I've got 4 x minus 1 squared minus 3. So I'm going to solve this with the square root property. So I'm going to add 3 to both sides. And then I'm going to divide by 4. Uh-oh, there's a fraction. And I'm going to take the square root of both sides. Now, you know when you take the square root of both sides, you're going to have an answer that's plus or minus. I know that the square root of 4 is a 2, so I don't have a square root left in my denominator anymore. But I do have a square root of 3 left in the numerator. And then my square root cancels my square, so I have x minus 1 here. So add 1 to get x by itself, and you're going to have 1 plus or minus the square root of 3 over 2. So my 0, x equals 1 plus or minus the square root of 3 over 2. So each of those I was able to do without even seeing a graph for the quadratic. So I want you to try that same thing here on number 4. So pause the video, work out the y-intercept, the range, and the zeros for example number 4, and then unpause and check your work. Okay, let's see how you did. So to find our y-intercept, we put a 0 in for x, and you could actually set the your calculator to get for the range. I look at this vertex form, and I know that my vertex is negative 9, negative 48. And so that 3 in the front tells me that my quadratic is opening up. That means the vertex is the lowest point on the graph. So all of my y values are going to be greater than that y coordinate the vertex is negative 48. And then for the last part of this question, your zeros, that means when you have your function equal to 0, so you're solving for x. So again, using square root property. So add 48 to both sides, divide by 3, take the square root of both sides. And unlike example number 3, we have a perfect square here. And then we need to solve for x, so we need to subtract 9. And you don't want to leave your answer as negative 9 plus or minus 4. You actually want to take that and find out what both of those answers are. So negative 9 plus 4 gets us that negative 5, and negative 9 minus 4 gets that negative 13. All right, last example. Example number 5. We're going to do the y-intercept first. So we're putting 0 for x. So negative 9, 0 plus 6 squared plus 45. Type all of that into your calculator, including the parentheses. What you should end up with is probably the smallest y-intercept 15, which is negative 279. The vertex of this quadratic is a negative 6, 45, and that negative 9 in the front tells me that my quadratic opens down. So that means this vertex is the highest point on the graph. So that for my range means that all of my values will be less than or equal to 45. So since the vertex is the F point here on the graph, all the other y's are going to have to fall below that. And then for the zeros, we're going to say 0 equals negative 9 x plus 6 squared plus 45. So subtract 45. And then you're going to divide by negative 9. And now we're going to take the square root of both sides. So this is plus or minus the square root of 5. And then square root cancels the square, giving you x plus 6. And then subtract 6 from both sides. So you've got negative 6 plus or minus the square root of 5. So our zeros, we just write as x equals. Okay, so that does it for the review of these analyzing graphs. Go ahead and go on to your homework that will include these graphs and some of the other stuff that we've done in this unit as well. Have a great day.